We've had a look at the graphs of the inverse trig functions arcsine, arccos, and arctan. These are the kind of questions you might need to answer involving inverse trig functions. Basically, you could break them down into three categories. One where you sketch the graphs using transformations. Two ones where you just type them into a calculator, very straightforward. And ones where you have to go from arc sine x equals y, take sine of both sides and make it x equals sine y. Then you'll use a kind of trig identity and do some rearranging and hopefully end up with the answer you're trying to get to. So if you take the first type where you sketch the graphs using transformations, here's an example which is fairly straightforward really. If we were to, if you want to sketch this graph, I would start by sketching, if we let fx equal arc sine x. So I'd sketch the arc sine x graph, which was explained on the previous video. And then it's just normal transformations, which you did at GCSE, you did last year. So if you do 2f of x, that will give you 2 arc sine x. So that's obviously just a stretch in y by scale factor 2. And then if you were to then do 2f of x plus pi over 2, that would give you the answer you want, which is that would just be a translation in the positive y direction, pi over 2. So it's very straightforward, those kind of questions. Now these are even easier. If you're asked to find in terms of pi the value of this, you just type it into a calculator. So you would just type cos, you have to shift cos and then just half. Make sure you put brackets around these and close the brackets, but it's pretty hard to go wrong here, I think. I got minus pi over 3 for this. Obviously you've got to be in radians because it's talking about pi there. Oh, I forgot to say before, if you want to practice questions like question 1, then you can practice those. If you really feel the need to practice typing things into a calculator, then you could do this question. What's generally more likely to be on your exam is questions like this, question 3. Now they're not really in exam questions that often, but when they are, students often find these kind of questions very difficult. So I've just got 2 examples here which will hopefully help you to understand this. Okay, so example 1 is just taken from the textbook, page 161, question 6b. I think this is a good example to practice inverse trig functions with. It says you start with this and you've got to end up working out what cos is in terms of x. So if we start by writing down arc sine x equals k, then what you generally have to do with these questions is take sine of both sides. If you take sine of both sides, it will cancel, sine and arc sine cancel, so you'll be left with x on the left hand side and sine of k on the right hand side. Now we want to find a way of going from sine to cos, and you're probably very familiar with using that, which is going to help us out here. So if we square both sides, we'll get x squared equals sine squared k, and then we know that cos squared k is going to equal 1 minus sine squared k from this up here. So cos squared k is going to equal, don't forget sine squared k is x squared from this, isn't it? So this is just 1 minus x squared. So let's write that over here. So cos squared k is 1 minus x squared. And we don't want cos squared, we just want cos. So if we square root both sides, by the way, everything's positive here because of this. You might want to also have a look at parts A and C of this question. I've just kind of skipped to part B because this is kind of the key part of the question, but it's also worth having a look at parts A and C. So let's just finish off the question then. So if we square root both sides, we're going to get that. So that's the answer to part 1. Part 2 is slightly easier because if we want tan k, we know that's sine k. So we're using this now, sine k over cos k, and sine k is x, and cos k, we've just done it, cos k is the square root of 1 minus x squared. And so that's the answer to part 2. Now we look at this second example. So it starts off in a similar way. You can see that you're given this, but this time you need to find arc sine x in terms of y. All right, so as we did above, it's probably a good idea just to write down y equals arc cos x, and then you want to do cos of both sides this time. So if we do cos y on the left, cos and arc cos will cancel, so that will give us an x there. Now it's not obvious what to do next, is it? We know we need to end up with arc sine though. We need to end up with arc sine x at the end. So the way to do this one is, well, there's a bit of a hint over here where it says hint. If you know that cos y equals x, then if we do this over here, so if we do cos y, so if we just replace the x's with y's over here, cos y is the same as sine of pi over 2 minus y. That just comes from the properties of the graphs of sine and cos. The sine graph is the same as the cos graph translated pi over 2 in the x direction. So that means we can just, instead of this cos y, we can replace this cos y with sine of pi over 2 minus y. So let's do that then. The left hand side now becomes sine pi over 2 minus y, and we're almost there because we want to find arc sine x, remember. So if we just do arc sine of both sides or inverse sine of both sides, that sign will cancel. So on the left hand side we'll have pi over 2 minus y. Just going to rub this out. We'll have that on the left hand side, but we'll have arc sine x on the right hand side. So by taking arc sine of both sides or inverse sine of both sides, that's the answer. We've now got arc sine x on its own in terms of y. So that's our final answer. If you want more practice on these kind of questions, as I said, these are the more awkward kind of questions you might be asked to solve on inverse trig functions, then I suggest you have a go at the questions over here, and also the questions here. But they do take a bit of practice, so But keep trying at them, and the more you do of them, the more likely you'll get the hang of them.